If you want to learn NumPy but didn't find the occasion to do so, this video is for you. I tried to sum up 27-ish functions of NumPy in this 20-30 minutes video. I will teach you how to create your first array, what you can do, like managing it and etc., the operations, how to do slicing and indexing, and as well some statistical functions you can use on your arrays. So, hope you enjoyed this video. Leave a like, subscribe, and let's go. Alright, so if you don't have NumPy installed on your PC, it's actually very easy. Here, so pip install NumPy, and then you run the command. I already have it installed on my computer. Alright, so let me hide this, and let's go. To import NumPy, you do a import NumPy and then as NP. NP is always a naming convention that everyone uses. It's a very good practice to do even so. Now, NumPy is all about creating an array, managing it, and then doing some basic operations with it. Basic, advanced, intermediate, all you want. Now the first step is how do we create an array? To create an array, there is mainly 4 ways to do so. Either with a shape or value from an existing list, from numerical ranges, or from random numbers. Now to create an array from a shape or a value, you simply give a shape or a value to a NumPy function. Now let's see, there is actually 2 ways. Either you can create a 1D array by passing an integer, or by creating a n-D array by passing a tuple. So let's see an example. We want to create an array of zeros. How would you do it? Very simply, you do a np.zeros. You specify the number of elements. Here np.zeros of 5 will return a 5 length array. Now let's say you don't want to create an array of zeros. You want to create an array of ones. How would you do that? It's actually very easy. You do np.ones specifying 5, the length. Now if you want to create an array of 2s, do you do np.2s and then you specify 5? Aha, this doesn't work. To fill an array with 2s, you do np.full. You specify the size and the number with which you want to fill it. So if I do np.full 2, it will fill it with 2. I can also do it 2.5, it will fill it with 2.5. Now how do we create a 2D, 3D, 4D or 7D array? It's actually very easy. Instead of passing here an integer, you will pass in a tuple specifying the row. First element is the row, second element is the column. So let me remove these ones. Let's retry again. You see here that is an array of 5 rows, 1, 2, 3, 4, 5, and then 3 columns, 1, 2, 3. You can also specify as much rows and columns and elements as you want. For example, here we have 5 rows, so 1, and then 2, 3, 4, 5. In each row there is 3 columns, so 1, 2, and 3. And in each column and row there is 2 elements, so 1 and 2. And same goes for np.ones and np.full, specifying the number with which you want to fill the array. Alright, you can also define a identity matrix, for example np.identity. Now the identity matrix has the same number of rows and columns, so just specify one of them. It will return this matrix right here, where in the diagonal you have ones and otherwise you have zeros. Alright, this was the first way of creating an array. The second way is from an existing list. Let's say you have a list called a list. Let's say you have this list right here, and then 4, and then 5. You want to convert this list to a NumPy list. All you gotta do is np.array, and then a list. Alright, so if I go ahead and print this, now this list is a NumPy array. You can specify the data type, for example, if you want to deal with floats or integers. For example, data type is equal to np.int. You have int of 16, 32, 64, 8, depending on the precision you want to use. For example, int32. I run this. It is an array of ints. Now if I change this to floats, it's an array of floats. By default, it's float 64. You don't always need the precision offered by the float 64. Often a float 32 is way more than enough. You can also do this in 2D. Let's say I create another array. Let's say blist, and then is equal to... Now I created here a multi-dimensional regular list. If I run this, it will create a matrix where we have here the rows and then the columns. This array has to be homogeneous. If, for example, I make it non-homogeneous, like this, you see that we get a somewhat warning saying that it is deprecated. But if we specify here the data type as object, data type is equal to object. When mentioning data type is equal to object, in a way, it will say that this first element is a list, and this second element is a list, making it more or less homogeneous. Now when it comes to functions and mathematical computation and numerical computation, you will often see people creating NumPy arrays with numerical ranges. You have two ways to do so, either by specifying the number of elements or by specifying the spacing between each element. You have a np.arrange to do so, specifying the lower bound, the upper bound, and the interval or the spacing between each element. If I run this, you'll see we have 0, 1, 2, 3, 4, 5 until 9. But notice that we don't reach this upper limit right here, since we are starting from 0, remember. And the second way is to specify the number of elements. And to do so, you use np.linspace between 0 and 10. And let's say we have 10 values. Now we see it did not give us the same result as this function right here. You see here we have 0, 1.111, 222. 10 represents the number of intervals. If we do 10 plus 1, we have here 10 intervals, so 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have n plus 1 points, so n interval is equal to n plus 1 points. Now the fourth way to generate or create NumPy arrays is with random numbers. You can either create an array with natural random numbers, so np.random.randint. You specify the lower bound and then the upper bound, and then the shape. For example, I want 3 by 3. I run this. See here we have an array of random numbers between 0 and 10. If I rerun it, we get different numbers every time. Of course, I can do here minus 10. And I should specify here that it is integers, because integers can be both positive and negative. Alright, so then we can create random numbers between 0 and 1 with the np.random.rand. But this time, we don't specify the shape as a tuple, but as regular parameters. For example, 3 and 3. This will give an array containing random numbers between 0 and 1 with a shape of 3 and 3. If I wanted to have a 3 times 3 times 3, I just add 3 like this. Now the third way to create an array using random numbers is with a random distribution. So let me actually remove this. This is not the case. Alright. And then the third way is an np.random.rand again, but you add an n to specify it as a normal distribution. You specify 3 and then 3, for example. You see here we have -1.3 and then 0.5 and then 0.84. Now if I highlight this function right here, it says it generates an array filled with random numbers from the Gaussian distribution of mean 0 and a variance of 1. You can also do with a 1D array, and we have this array right here. Now we saw the 4 ways of creating a NumPy array. The next question is, what can we do with these arrays? Alright, so let's see right here. There is actually a lot of ways you can manage this array and manipulate it using NumPy. The first way, you can actually view its shape by doing a vector.shape. Okay, we run it. You see here it returns a tuple containing the number of rows, so 1 and then 2, and the number of columns, so 1, 2, 3, and 4. Right, so now there is a lot of way to actually reshape and change the size of your vector, for example. You can either transpose, flatten, reshape it, and etc. Let's say we have this array right here. It's made up of 3 rows, so 1, 2, and 3, and 4 columns each, so 1, 2, 3, and 4. We can first transpose this vector using the vector.t for transpose. We have 4 rows and 3 columns, so 1, 2, and 3. We can also flatten our vector using the np.ravel vector. So if we run this, you'll see now that we have a 1D flattened vector. Transforms any ND arrays into a 1D array. But let's say we want to reshape this array right here to another shape. Let's say np.reshape our vector. If you just specify -1, it will do the same thing as the Ravel. But let's say we want to have 2 rows and the remaining columns. I do 2 and then -1. It'll give us 2 rows, so 1 and then 2, and the remaining columns. So since here we have 3 rows and 3 columns, it's in a way 3 times 4, it's 12. So these 2 values have to be in some way a multiple of 12. For example, 3 and 4, then 2 and 3 and 2, then 2 and -1, 3 and -1, and etc. For example, I can do here 3 and then -1. It will give the same initial vector. But I can also do, for example, 3 and then 2 and then 2. It'll give us a vector with 3 rows, 2 columns, so 1 and then 2, and then each column we have 2 elements. Notice that if you do 3 times 2 times 2, it will give 3 times 4, which is equal to 12. Now, if you have a vector in NumPy that you want to copy, for example, you have to keep in mind that when you do vector A is equal to vector B, both vector A and vector B will point to the same address. So to avoid this problem, you can use the np.copy. Let's see, for example, I create another array called array B, which is equal to array A. Alright, but let's say now I want to change, and I decided to change, the elements of array A. So let's say that this element right here is equal to 1. You see that now it's 1, 1, 2, 3, 4, 5. But the thing is, if we go ahead and print out B, we will see that B is also actually being updated, whereas we didn't explicitly do it. You can go ahead and type in a quick boolean check to see if A is equal to B, array B is array A. You will see that will give us true. But now here, if we use the np.copy function, so np.copy A, and then we retry it again, you'll see that now it is completely different arrays. And if you go ahead and print out B this time, you'll see that it kept the initial 0 from here, and it didn't get modified after doing this line of code. Now we can also add elements by appending, concatenating, or stacking them horizontally or vertically. Let's say I have two arrays, array A and array B, from 0, 1, 2, and then 3, 4, 5. If I do, for example, np.append, then I mention array A with array B, and then here it's double P. Right, I run this. Now you can see that we appended the array B to the array A. Now you can achieve this also by using the np.concatenate. Here you have to specify a tuple of array A, so the first array, and array B, so the second array. I run this, and you get the same result right here. There's also two other functions called np.vstack that will stack the first array to the second array. If I do the exact same thing, you can see here that it stacked the array A with the array B vertically, so this is vertically, but I can also do it horizontally, copying this, changing the V to an H, and this to horizontally. I rerun this, and you can see here now we have a horizontally stacked array. But you can also delete elements. For example, here I have a 3 by 3 matrix. If, let's say, I want to delete the first element of this matrix right here, I'll do a np.delete. I specify the array, array A, and I specify the index. See here, now it deleted the first index, this one, and it returned to us a flattened array. Now let's say I want to delete all this row right here. This will be specified as the row with index 0, and then this is index 1, index 2. And the column, this column is index 0, this column is index 1, and this column is index 2. So for example, if I say index 0 and I specify the axis is equal to 0, so axis is equal to 0 refers to a row, so let me actually do this. Alright, let's see. If we delete this, we can see that we deleted the first row right here. Now if I specify here axis 1, it will delete the first column, like so. Here, you can see that 0, 3, and 6 was deleted. Now to sum up everything we did till this point, we saw how to create an array with the 4 ways, remember? Now we just saw how you can manage an array by reshaping it, changing elements, adding, removing elements. Now the third step will be to see about array operations. It is a bit the key and the heart of NumPy, which makes it tremendously useful. Alright, now when it comes to operations in NumPy, you have to know that NumPy is self-conscious. It already knows that it has to perform element-wise operations. Now we have the basic operations, the element-wise operations, including the arithmetical operations and the comparison operators. For example, if I have an array right here, I can simply do array then plus 2. This will add 2 to each element of this array. Also make a multiplication. So basically all the arithmetical operators, you know, the addition, the subtraction, multiplication, division, modulus, and exponentiation. For example, I can do exponentiation of 2. So 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, etc. Of course, you can also add two arrays together. For example, if I have two arrays, array 1 and array 2, let's call this 1, let's call this 2. I of course can do array 1 plus array 2. Like so, I run this. And see here, it did 1 plus 1, 2 plus 2, 3 plus 3, etc. You can also multiply them. It will do an element-wise multiplication. For example, 1 times 1, 2 times 2, 3 times 3, and etc. Same goes for division, and so on. Alright, another interesting thing is that you can also use comparison operators. For example, I have array 1. I can do array 1 greater than 2. See here, it returns an array of false and trues. It will do this condition element-wise. It will check for each element if it is greater than 2. If it is, it will return true, for example here. If it is not, it will return false. So for example here, we do is 1 greater than 2? False. We return false. And then is 2 greater than 2? This is not true, so we return false. 3 is greater than 2, and same goes for the remaining rest. You can also do an is equal to, like so. You can also do not equal to, like the basic comparison operators we know. Now this can be pretty useful down in the third or fourth section right here in indexing and slicing, but we will come back to this a bit later on. Now Numpy also provides a wide range of mathematical functions, including trigonometric, hyperbolic, exponents, logarithmic, and basically everything you can think of. Let's consider, for example, here an array called theta, which is equal to np dot from 0 all the way up to np dot pi. This is a defined pi constant within Numpy, and then across 100 points. I can do y is equal to np dot cos of theta. Now I can go ahead and print y, like so. Here it is. Now let me actually import matplotlib to actually visualize this function. So here, if I run this code right now, by importing matplotlib.pyplot, just to see the plot of y, you can see here, this is our cosine. Now I can actually do it from 0 to 2 pi, and then we will be able to see it better, like so. You see? Of course, I can do a addition right here. This is also element-wise, by the way, so it will apply the cos function to each element of theta, and then it will return a vector y. So I can do here np.cosine plus np.sine. It is entirely possible, like so. And of course, I can square it. Then here, I rerun the code, and then here it is equal to 1. Shocking, I know. Alright, so you can also do it with, let's say, a log, or basically any function you want. Here, let's see. Alright, let me go back to sine. Now, the third way you can think of operations in Numpy is by using broadcasting. Now, Numpy supports broadcasting, which allows you to perform operations on array of different shapes. For example, here I have two arrays, array 1 and array 2. This array, so let me do it like so. Alright, so we have 2 rows and 3 columns. And here we have an array with, let's say, of 3 elements. Now when I do array 1, if I do array 1 plus array 2, you can actually run this, and you will see it will give us this result right here. So what it does is actually take this array right here, and then add it to the first row, and then take this array again, and add it to the second row. Now of course, if you do 10 and then 20, this will not work, because it is not homogeneous, and it cannot perform this operation right here. You see, we have an error. Operands could not be broadcast together with shapes 2 and 3 and 2. You can also do a subtraction, and you can do a multiplication, of course. This will take this element and multiply it by this element by this element, and then 30 by 3, which is 90. And then it goes to the second row, and it does the same thing. Alright, this was a bit a overview on the operations you can do with Numpy. Now the fourth thing I want to discuss in this video is about indexing and slicing. A very interesting concept you can do in Numpy. So let's actually see it. Alright, you will notice that the background is changing again. This is actually the next day, but never mind. Alright, so indexing and slicing. When it comes to indexing and slicing in Numpy, there are powerful techniques you can use. You can either do a single element indexing, a multi-dimensional indexing, and a Boolean indexing. Now when it comes to single element indexing, it's exactly like regular lists. For example, here I have array 1. I can do array 1 and then specify 0, for example. I run this. You see here it specified the first element. I can also do, for example, -1 to see the last element, like so. It displayed 5. If I want to display, let's say, the second, third, and fourth element, you do it like we always do. You specify the index of the first element you want to display. So we want to display the second element, let's say. This corresponds to the index 1. So it's 0, 1, 2, 3. We will not do 3 since it's not inclusive here. We will do 4. Alright, so you can see it printed 2, 3, and 4. Now, if we have a two-dimensional array, it's more or less the same principle. So let's say we are speaking about array 2. So if I say array of 0, this will give me the first row right here. And then if I want to access the first element within this row, I just add another 0 right here, comma 0, and I rerun this. You see here, now we have access to this element right here. Now if you want to display the two first elements of this column, so this column and this column within the first row, you specify the row is equal to 0, and then here when it comes to the column, you want to display from the 0th element all the way to the 2th element. So when you say 0, 2 dots 2, this means that 2 is not inclusive. Right, you can see here we printed 1 and 2. You can also do, for example, 1 and then 2. See here we printed just this element right here. If we want to print 2 and 3, we just remove this 2 right here, 2 and 3. So if you do 1 and then these 2 dots, it means that in a way start from index 1 and then take everything that is after index 1. Of course we can do this with the second column and so on. If you want to display just the first column, for example, not a row, we want to display all the elements of the row. So for example, this row and this row and this row. And then in each rows, we want to see either the first element, for example, like so. We run this. Now we have 1, 4, and 7. So 1, 4, and 7. If you want to display the two first block, so this one, and then this one, we want to iterate through all the rows, and we display the first two elements. So I can do 0, and then 2. You can see here, we have 1, 2, 4, 5, 7, 8. Now you see here what we are doing. There is something you can also do with Boolean indexing. We spoke a bit earlier about comparison operator. So when we do, for example, let's say array 1 is greater than 3, this will return an array of false, 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 true, and true. So this is called, in a way, a mask. So this will be a mask. Now if we take this mask and apply it to array 1, make array 1, and I apply it this mask right here between the brackets. Now you can see we only get 4 and 5. Interesting. So let me rehide this. Now you see here we have 3 falses and 2 trues. Now when you apply this mask to this array, when you have a false, it will not return any value. Now the index where the true value is will return the element of the array. For example, here it will be 4 and 5. See? 4 and 5. So here is another example where we have an array of -1, 2, 3, 4, and then -5, 6, -7, 8, 9, and then 10. We can reapply a mask, for example, saying the elements that are odd or even, so array 1, and then modulus 2 is equal to 0. You'll see we have an array of falses and trues. Of course we can apply this mask, right? So I do like array 1 and then I apply it to the mask. Like so now we have only the even numbers. Now let's say I want to add the odd numbers. I change this to 1. Now we have the odd numbers. Now let's say we want to filter it one more step, where we want to remove all the negative numbers within this array right here. Now the thing is, with this type of mask, you can actually stack conditions. Right? So this is our first condition. But let me actually do it a separate one. If I do this, remember this is our first condition, I run this, is true and falses. I can do another condition, the same one, that will check if array 1 is positive, like so. This will return the elements which are positive within array 1. So for example, the second element, third and fourth, second, third and fourth, and then sixth, and then eighth, and ninth, and 10th. Alright, but the thing we can do with NumPy is you can actually stack these two conditions. You can stack them just like you can do then condition and condition, or condition or condition. Right, so let me actually print these two conditions separately. So print this one, then we print this one, like so. As you can see here, now we have the two conditions, the first array and the second array. Let's say we want to stack these conditions, so let me do a third print where I will copy this statement right here. I'll make this, and this. Now we have these two conditions, 1 and then 2. To actually do an AND gate, you can either do this symbol right here, and then we run the code. You can see here we have true and false, result in false, so the basic AND gate. Now we can achieve the same thing doing a multiplication. You see here, it is the same thing. Now if you want to have this condition or this condition, you can either do a plus, like so, or you can also use this symbol right here. It's like a line, resembling an L, but it's not an L. It's a symbol, let's say. Alright? Now, if you have these two conditions, you can take this as a mask. Let me remove all of that. I'll call it a mask. Alright? I'll replace this with an AND gate. Okay? And then I apply this mask to array 1. And you can see here, remember, we want to filter out the odd numbers which are positive. If we just apply the odd numbers, we will get -1 and then -5, -7. But since they are negative, in this mask right here, they are going to get filtered out, and only 3 and 9 will remain. Alright, so this is a bit of the basic things I want to show you when it comes to slicing and indexing. You can do very complex things with these two notions of slicing and indexing. So I'll let your creativity decide of it. And then the last thing I wanted to speak about here is some statistics function in NumPy. So let's say I have an array right here of data, which is equal to numpy.array. Very simple array of 1 all the way up to 5. We can display the average, which is 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which is the number of elements. Now if you had, for example, a multi-dimensional array, can display the average of data, like so. You see, it gives 5. So it does 1 plus 2 plus 3 all the way up to 9, and then it computes the basic average we know. Now I can, for example, specify the axis. For example, I do axis is equal to 0, and then I run this. It will return 4, 5, and 6. If I specify the axis to 1, it's equal to 2, 5, and 8. So in a way, how it's operating, you see, when you specify axis is equal to 1, remember, it's about columns, right? You see, it computes the average of all the columns within one line. You know, so this is the average of all the columns, so 2 here is the average of all these columns within the first line, or the first row, and then the second row, and then the third row. Same goes for axis is equal to 0. See, here we have 4, 5, and 6. So it computes the average of the rows within the first column, and then the average of the rows within the second column, and with the third column as well. Alright, so you have np.average. Now when it comes to a 1D array like this one, you can also use np.mean, which gave the same result, and np.median. Alright, so let me redo that on average. Okay. We can also extract the minimum, the maximum, and the index of these within an array. For example, I do np.min data, like so. It returns 1, which is the least element. So if I do, for example, 1, 2, then -3, you can see here it returns -3. If I do arg min, this will return the index of this minimum right here. So the index is 0, 1, and then 2 here. The index is at 2. Same goes for max. I can do an np.max and an np.argmax. if you want to have the sum of this array right here, you can do an np.sum. Very basic. Okay, you see here 9. Same goes for this one, np.sum. I can also specify, I think, the axis. So axis is equal to 0. It will return an array of the sum of all the rows within the first column, and then all the rows within the second column, and all the rows within the third column. Same goes for axis 1. Right, so with that we saw most of the functions I wanted to cover in this video. By now I hope you have a better idea on what NumPy is about and its function. Remember how to create an array. Like, let's do a brief summary. We saw how to create an array with the 4 ways, remember? And then let me slightly scroll down. We saw how to make array management, so to display the shape, and then how to make the transpose, flatten an array, reshape an array, how to copy an array, and also how to stack them and concatenate them. We saw the array operations you can achieve with arithmetical and comparison operators, as well as the mathematical operations and the broadcasting. We then saw about indexing and slicing of NumPy arrays, and finished with some additional statistical function in NumPy. So let me actually do this, copy this, and like, for example, all of these ones. So yeah, hope you enjoyed the video. Now if you want to learn how to apply these functions to practical examples, check all of these videos right here, and see ya.